Hello and welcome back to Math 8. This is a video over Section 2, and we're going to be talking about rate of change in an introduction to slope. So we've been talking about this so far, but what I want to do is talk about rate of change. So up here I want to write rate of change, okay? And a rate of change is the comparison of two values by division, okay? And what I want to think about is a couple of real-world examples, okay, of rate of change. And when I think of rate of change, I often think the one I think of the most is miles per hour. So miles per hour. Okay, so I'm taking two values. I'm taking distance and time, and I'm dividing them. And this gives us our rate, okay? And this is something that we're pretty familiar with, okay? If you go and buy gas, you're going to have a cost per gallon, okay, of gasoline. So those are rates that you see. Anything where it's, something per something is a rate of change. So, these are just a couple of examples. But let's go down, and we've been talking about, the different types of rates of change. And let's talk about this. So in this example, we've got that this graph shows the distance Andrea bicycled over time. Is she traveling at a constant rate of change? So the first thing we want to do is find a couple of different rates of change given various points. Okay, so what we're going to do is we're going to calculate the rate of change of the slope from 1 to 2 hours, and then we're going to do the same thing from 1 to 4 hours. Okay, and let's say this 1 to 2 hours. So let's copy these points down. Here's 1 to 2, okay? And this slope, if I wanted to calculate this slope, I rise over run, I went up a distance of 10. And I know I went up a distance of 10 because I'm looking at my scale here. Each one of these distances is 10, okay? Now over here, this is, these go up by 1 hours, okay? So 10 over 1, all right? And what we can figure out between 2 and 1, or 1 and 2, so here's 1, okay, is that the distance goes up 10, okay, 10 miles per 1 hour. So what I have, the rate of change, which I'll call my slope m, is equal to 10 miles per 1 hour, okay? And so you can write it like that, or you can just say 10 miles per hour. Okay, same thing. Okay, now let's find the rate of change from 1 to 4 hours. All right, so in that, I'm going to go from 1, change colors, 1 to 4. Okay, and I'm going to go do the same thing. Do my slope, go up, and then over. Now, what I see that I've done is I've gone up 10, 20, 30 miles. Okay, and I move over 3 miles. Okay, so let's do that one. And on this one, I get that my slope is equal to 30 miles per 3 hours. Okay, now I can divide these numbers. 30 divided by 3 gives me 10, and so I get 10 miles per hour. Okay, and so I can use these things to use these graphs to find out how fast someone's going. Okay, and notice what I'm doing here. I use my labels to help me. So I use labels when finding my rate of change. Okay, ROC is rate of change. All right. So then it asks, what would you deduce Andrew's rate of change from 4 hours to 7 hours? So this is a constant rate of change because we're getting the same thing, okay, for 1 to 2 hours, 1 to 4 hours. This is a constant rate of change, meaning the speed doesn't change. So we can, assume here from 4 to 7 hours is that the speed m will be equal to 10 miles per hour. Okay, so does it matter what interval we use. You know, can I use 1 to 2? Can I use 1 to 4? Could I use 4 to 7? And it doesn't matter. Okay. So when you find a linear equation, it does not matter when it's linear. Okay. So doesn't matter when it's linear. Okay. Otherwise, if it's not linear, then it actually does matter. Okay. All right. So let's continue talking about the slope. Now, what we can do is we can calculate the slope given 2 points. Okay. And oftentimes, what you guys will hear teachers do is talk about rise over run. So, you know, and we've been talking about this quite a bit. Okay. Slope is rise over run. Slope m is equal to rise over run, okay? And we also can call it the change, okay? This delta here means change, okay? Change in y divided by change in x, okay? Same thing. Now, given 2 points, okay, we could also calculate the slope using this formula, okay? So given 2 points, okay, and we're going to call those points x sub 1 comma y sub 1 and x sub 2 comma y sub 2, okay? And what I'm doing here, this is my first point, okay? That's where I get these values of 1 here. And then the 2's mean that this is my second point. Okay, and that's it. All right, so let's do this. Let's identify a couple of points on this graph, okay? And so I'm going to do this point here, and this point here. So I can identify 3 points on this graph. Let's just go ahead and use these points here. Now I'm going to call this point 0, 1. I'm going to call this point 4, 2. All right, now if I talk about my rise, okay, change in y, okay, and then my run, let's use green. Okay, my run, that's my change in x, okay. So let's think about this. Now I'm going to rise up 1 unit, okay, and then I'm going to run 4. So that's an easy way for us to do this. My slope is just going to be 1/4. Okay, I already know that. Okay, but the question is how do I get 1 and 4 by using these points? Okay, because it's not always going to be a nice, easy graph that's on an actual point. Okay, and what I want to do is this. I want to think about the distance, this vertical distance here. Okay, 2 and 1. All right, so to find the distance between 2 and 1, okay, you know, all I would do is subtract my values 2 minus 1, okay? So my slope m, all right, I could use my points, and that would give me 2 minus 1. All right, now, on the run aspect, okay, this distance, I'm going from 4 to 0. All right, so 4 to 0, and I have a distance of 4. So using those numbers to get 4, I would take 4 minus 0. So 4 minus 0. And so what I would end up getting here is I would get my slope m, and this should be in blue. I don't know why I did this in red. So my slope m, 2 minus 1, is going to give me 1, and then 4 minus 0 is 4. So my slope is equal to 1/4. Now remember, okay, this is my first point, x1, y1. This is my second point, x2, y2. So when I do this, you know, essentially what I'm doing is I'm calculating my slope between these 2 points and saying y2 minus y1 over x2 minus x1. All right, and that's my slope, okay? And you can see that same thing over here, okay? So we're going to use this quite a bit. I wanted to show you graphically, you know, you can do the rise over run. But, if you don't have a graph, you're just given 2 points, we can use this formula as well, okay? All right, so let's do that. All right, let's do it here. So it says find the slope of the line that runs through the points given in the table. So we don't have a graph, so we can't do rise over run. But what I want to do is first translate these to points. All right, so this is going to become the point -1, 6. This is going to become the point -3, 0. Now what I'm going to do is I'm going to call this my first point, x1, y1. Call this my second point, x sub 2, y sub 2. Okay? And so with this, all right, I'm just going to plug it into my slope formula. So m is equal to, let's do this, y2 minus y1 over x2 minus x1. Okay, therefore, for these points, I'm just going to plug those numbers in. So I've got 0, which is y2, minus 6, which is y1, divided by -3 minus -1. All right, so what ends up happening here is I'm going to get 0 minus 6, which is -6, -3 plus 1. All right, so this is -3 plus 1, which is going to give me -6 over -2. So now when I divide those numbers, my slope, my rate of change between these 2 points is going to be 3. Okay, -6 divided by -2 is positive 3. All right, and so that's what we've got. All right, and so that's what we're doing with those points. Okay, I know I probably wrote off the page a little bit, but do your best and just write small. Okay, so make sure you're writing over here if you don't have any more room. So, all right, let's go to the next page. All right, so in this example, it says the car represents, the graph represents the linear relationship between car one's time and distance. So your x-axis is time, your y-axis is distance. Okay, so when I think about this, if I'm going to write about my slope m, oftentimes what I do is I'll take my label and put miles over my x-axis, which is minutes. Okay, so we have this rate of miles per minute. Okay, and we can calculate that rate. Okay. So let's do that. All right, so let's just take 2 random points. Okay, it doesn't matter which ones we use. I'm going to use 0, 0 because I like operating with 0. And then let's just do 2, 2. Okay, so if I rise up here, my slope is going to be equal to a rise of 2 miles over 2 minutes. Okay, now I know that I am going, or this car is traveling at 2 miles per 2 minutes. Now, if I divide out my 2's, I'm left with 1 mile per minute. Okay? Now, what I can do is turn that's my rate. Okay? And I know that that's a constant rate because we're going in a straight line. Okay? Now, if this is curved, then our speed would be changing. Okay? But for right now, we're just traveling at a constant speed of 1 mile per minute. Now, let's think about this for a second. 1 mile per minute, let's change that to miles per hour. So miles, 1 mile per 1 minute. Okay, and what I want to do is change this into miles per hour. So I'm going to multiply this by 1 minute, or no, not 1 minute, let's do 60 minutes. Okay, per 1 hour. Okay, and what I'm able to do now is I'm able to divide out my minutes. Okay, so if I multiply that by 60, 60 minutes per 1 hour, then I get 1 times 60, which is 60, and this is miles per 1 hour. And so that's how fast the car is going. Okay, I don't think we're going to need to do any unit conversion, but I just wanted to show you that that's how we do that. Okay, now here, all right, the table represents a linear relationship between car 2's time and distance. What do you notice about the speed of the car? Okay, so here, let's do this. What I know, and this is where these tables kind of get weird. This table is going up by 1 in that part, going up by 2, and then going up by 3. Okay, and what I'm noticing here is that, because those aren't going up by a constant number, I don't have the time at 3 minutes or the time at 5 minutes, okay, the distance isn't going to go up at a constant rate either, okay? However, all right, this goes up by 0.5, this goes up by 1, this goes up by 1.5. Now, here's what's going to happen, all right? Let's go ahead and let's do this, and let's figure out, what we get. So let's do the first problem, or the first one, and, I'm just going to use this first point here, okay, and this second point. So let's write those points down. I've got the point 1, 1/2. So 1, 1/2. I've got the point 2, 1, I believe. Yeah. Okay, and let's find the slope between these 2 points. All right. So here, what I have, my slope m, I'm going to call this x1, y1, x2, y2. All right, so I'm going to plug it in. I'm going to do 1 minus 1/2 divided by 2 minus 1. So my slope m is going to give us 1 minus 1/2 is 0.5. And then we're going to run, so 2 minus 1 is just 1. So my slope is equal to 0.5. And let's put a label on this. This is miles per minute. All right, so this is going at half the speed. So miles per minute. All right. Now, let's just verify that we do, in fact, get that same number. Now, what I'm going to do is I'm going to do this again, but I'm going to use the numbers 2, 1 and 4, 2. So let me plot those numbers down. So I've got the numbers 2, 1 and 4, 2. All right, same thing, x1, y1, x2, y2. All right, so now if I'm finding this slope, I'm going to do 2 minus 1, okay, divided by 4 minus 2. So 2 minus 1 is going to give me 1. 4 minus 2 is going to give me a value of 2. So I get the same thing. I get 1/2. Now I can write this as 0.5, okay, and this would be miles per minute, okay. Now, if this is going half the speed as that one, okay, this is going 1 mile per minute. This is going half a mile per minute, so it's half the distance. This car is actually traveling at 30 miles per hour, okay? So 30 miles per 1 hour, okay? And so, that's what I noticed. It's going half the speed. So your ability to take a look at graphs and tables and calculate the slope is what we're doing in this. So in the next couple sections, we're going to explore this a little bit more. And hope you enjoyed this video, and we'll talk to you soon. Thanks a lot. Bye.